James, in class, we kind of skipped over a few lessons. They were kind of fluffy, and it should be something that when you read through it, probably you'll be fine. If you have questions about it, you certainly can ask me or Mrs. Kentner. So I left off with you on lesson 89, figuring out square roots. We skipped over lesson 90. We looked at it, measuring turns. It's pretty self-explanatory. I did not assign the problem set. We just moved on and caught up. We did some of the examples and then just moved on. So I skipped over lesson 90 on measuring turns. Pretty self-explanatory. Read through that one. I have not yet taught investigation 9. I will be doing that soon, and we'll need to get you caught up on that one. Which is one of my favorite ones as well. We just haven't been able to get to it yet. I also skipped over geometric formulas on lesson 91. Again, very fluffy, simple assignment. So we looked at that and then moved on to what I'm going to work with you now on, which is problem set 92. It's expanded notation with exponents, order of operations with exponents, and powers of fractions. So you want to make sure you're looking at the right page when we start this. It's on page 479. There's a chart at the bottom that shows what the power number would be, and I'll put it here on the board in a minute if you were in trillions, millions, tenths, and so forth. So I'll take my book with me and just kind of do a real quick review here. When we were doing expanded notation, that was when we would take like old school, put my old school here, I might give you 63,582. And so the 6 is in the tens thousands place. You did that. The 3 is in the thousands, 3 times of 1,000. Plus the 5 is in the hundreds, the 100 there. And 8 times 10. And 2 times 1. Sorry if this went off the board. Hopefully you can still see it. All right. What you're doing now, instead of having to write out these big long names or numbers, we can actually do that using powers of 10, exponents with 10. Like 10 squared is 100. So here, where this is 100, instead of writing 100, we'd write 10 squared. And there's a chart, like I said, there's a chart on page 479 that shows you those shortcut numbers, but I'm going to show you a trick even faster. So just like I said, we know 10 squared is 100. Check this out. When we get in this position, you're going to write down a 10. How many zeros? 2. 10 squared. So it'd go like this. Instead of having to look at the chart and think, ooh, what's the power of 10 that I use on 10,000, you're going to write down 6 times, write down a 10. Now, how many zeros here? 1, 2, 3, 4. 10 to the 4th power. And if you multiply 10 times 10 times 10 times 10, you get 10,000. Your trick is 1, 2, 3, 4, write a 10 with a 4. So, I'll pause here. 3 times 10, think about what power? That's right, count the zeros. 1, 2, 3. 10 to the 3rd power. 5 times 10, what power? Well, 10 squared is 100, or count the zeros. 2. Try to write a little smaller here. 8 times, yes, you are still going to write down 10. 10 to what power is 10? 1. We've never used a 1 before, now it's time. There's 1 0, put a 1 here. When you are writing with powers. I'm sorry, I don't know if it's off the screen or not, but 10 on 2 times 1, you still have to use a 10. So you're going to say 2 times 10, how many zeros? Exactly, 0. And so 10 to the 0 power means 1. That's how you write exponents. So just really quick, if I gave you the number 9 billion, so we've got hundreds, thousands, millions, billions, and I said write that in expanded notation using powers of 10, 9 times 10 And what value gives us billions? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9's in the billions place. And compare that to the chart and you'll see that it matches. So that's that. Okay, now the second part of the lesson is, all right, we've been using the Please Excuse My Dear Aunt Sally acronym for a long time in class. So that's our second point. Please excuse my dear Aunt Sally. We've done a lot of this, so it shouldn't be too tough for you. But we've not done a whole lot with parentheses and exponents. So I'm gonna pull one from the book first, and then I'll make a challenge for you. So let's say I give you, this one's right from the book, James, 5 parentheses 8 plus 8 divided by the square root of 16 plus 3 squared times 2. Okay. Please excuse. We're going to put parentheses around that as a reminder. Do this first. Parentheses, exponents, then multiplying, dividing, adding, subtracting. Please remember, we put them in this order because it makes a great story. Please excuse my dear Aunt Sally. It wouldn't make sense to say, excuse please, dear my Sally Aunt. But remember that those things are equal. When I do parentheses and exponents, it's whatever comes first, left to right, like you're reading a book. So it doesn't have to always be parentheses first. It doesn't always have to be multiplying first. It's whatever comes first in the problem. We're going to simplify this in small steps. First thing I want to look for is, do I have any parentheses or exponents? I've got a parentheses here, so I can do that part first. And square roots are also considered exponents. I can simplify this before I do any dividing or adding, and I've got a square of a 3. I can do that. And in case that looked like 32, let me fix it for you. So I can take care of these numbers before I do any of the functions in between them. So I'm not going to change the 5. Minus 8 plus 8 is 16. I don't need the parentheses anymore. I'm not doing any dividing yet. Square root of 16 is 4. Plus 3 squared is 9 times 2. So what I check for is, do I have any parentheses or exponents? All done. I'm done with that. Move to multiplying and dividing. Anything connected by multiplying and dividing left to right first. So I have subtraction? No. I have dividing. Hey, but see, dividing was first this time, even though it's not first in the acronym. So I'm going to do this part first because they're connected. I have an addition sign. That's not multiplying or dividing. I have a 9 times 2 connected. I will do that part as well. 5 again did not get changed. Minus 16 divided by 4 is 4. Plus, haven't done any adding yet, 9 times 2 is 18. So I check up here, do I have any multiplying or dividing left? No. Now it's time to add and subtract. And once again, what comes first in the problem? In this case, subtraction did. So I can't cherry pick and say, I want to do that part first because I like it. I have to do this part first. So that's the only part I can do. I have to get this answer first, then I can add 18. So I'm going to have 1 plus 18. Now I can add that. Final answer, 19. Okay? If you had tried to go out of order and say 18 plus 4, that's 22. So then it would have been 5 minus 22. You would have come up with a negative number. So left to right. All right, what else is left? I set my book over here. Oh, the last part of lesson 92 is what happens when we have powers of fractions. Just like powers of any number, if I gave you 2 cubed, you know that means 2 times 2 times 2, and of course that final answer will end up being 8. It's the same thing with fractions. If I gave you 1/2, normally you'll put parentheses around it and put the power outside. I'm going to put a 3 there. That literally means 1/2 times 1/2 times 1/2, and so 2 times 2 is 4 times 2 is 8 over 1. So if I throw up a different fraction, I'll just use a traditional one. Let's say 2/5. 2/5, and I want to square it. If I put a little number here, it looks a little weird. That makes it now 2 squared. So that would be 4 divided by 5. That's not what I want. That's why if we want the whole fraction to be squared, we have to put parentheses around it first and then put our number. I'm going to put a 2 here. That means 2/5 times 2/5. That is different from saying 2 squared divided by 5. This one would be 4/5. I'm not going to change it. This one really means 2/5 times 2/5. Can't cross cancel, so it gives me 4/25. Do you see the difference? That's why we use parentheses. And you know what? I forgot to tell that to my class too, so I need to make sure we go back. I don't know if anybody's been missing that or not, but that's why we do that. Okay, before I go, and if I have enough film left, let's throw up a challenge for you. This is not with this lesson. This is going back to algebra. Been asking you on your worksheets to show me cross products, algebra settings. Here's another problem, just kind of I-steppy and futuristic. Let's say I gave you the problem 8m minus 6 is equal to 12. Now, I just made this up, so I might leave it in fraction or decimal, I'm not sure. Your job is to isolate the variable. The variable is the m, but you have to do it one piece at a time. So whatever you do to the left side of the equation to keep it equal, you do it to the right side. So we want to neutralize. We're going to use the inverse operation of everything that we're doing. My first job is, I want to get rid of this 6. I want to try to get 8m by itself. So 8m, I was subtracting 6. To neutralize that inverse operation, add 6. And what you did, you added 6 on this side, you have to add 6 on this side. 12 plus 6. Let's quickly simplify that. In your mind, these two neutralize each other. They become 0. So 8m minus 0 is still going to be 8m. Whatever 0, I'm taking 0 away from 8m. So that simplifies simply to 8m is equal to, and then 12 plus 6 is 18. Now I need to get rid of the 8. In this problem, I was multiplying by 8, so use the inverse operation to both sides. Divide by 8. I'm going to rewrite it again so you can see all the steps. Divide by 8, both sides, 18 by 8. These neutralize each other, becoming 1s. 1 times m is still going to be m. So when this all simplifies, I'm going to put it over here, James, I'm kind of out of room. M equals, now I have 18 divided by 8. Definitely could go ahead and cross cancel somewhat anyway. Let's see. 2 would go into both of those, so that's now 4 and that's 9. Okay, so now I'm dealing with 9/4. Let me work it over here. I'm gonna leave it in fraction form. 9 divided by 4 goes in 2 full times, the gazindas, and that would give me 2 and 1/4. Or I could add a decimal, carry it out, and give me 2 and 25/100. Either answer would be acceptable. So make sure you're neutralizing. If you have a subtraction or addition part separate from your variable, get rid of that first. Simplify it to both sides. Process that down. Now we're back to getting rid of the 8. Old school would just say, okay, just 18 divided by 8. But truly we're doing it to both sides. So just another little piece of how do you use algebra to solve. You're not going to have anything like this for several weeks, but it's coming, so I wanted to make you aware of it. Good luck, bud.